Hey, what's going on, y'all? It is Sean of Math Swap Tutoring, and today we're going to talk about radicals. Now, I've always kind of wondered why they call them radical. Like maybe it's like, radical dude, I mean, not really, but it's just interesting that they're called radicals. Um, but anyway, I digress. I'm just kind of being silly. As we get ready to start this, remember, if you actually are in need of tutoring right now, we'll be glad to help you. And you will want to go here, calendly.com/math swap tutoring to set up your tutoring, your free tutoring consultation. You can also call 478-254-0515. And then also the notes that I create to do these videos, I make them available to my subscribers. If you go to mathswaptutoring.com/subscribe, then you can find my notes and you can use my notes. Okay. All right, let's do this. All right, radicals. So all a radical is a way of expressing a rational exponent. Let me see, that is in the form of a fraction. Okay, so let's make that make sense. So and by the way, this is related to roots. If you watch my video on roots, you'll see what I mean, because roots uses that same radical bracket thingamajig or whatever. But it's very much related. All right, so anyhow, look at that video on your own time, and let's talk about radicals here. So again, let me say this: a radical is a way of expressing a rational exponent that is in the form of a fraction. All right. And if you recall, rational and irrational, rational is usually like a number whose decimal representation either terminates or repeats. So like, for example, you have like 0.5. That's a rational number. It's a decimal that terminates. Or you might have 0.3333333, and that's a decimal that repeats. So these are rational. So irrational might be something like pi, which is 3.14159, et cetera, or the constant e, which is 2.71828, and so on and so forth. In other words, decimals that don't terminate or repeat. All right, so let's make this make sense. So say, for example, we're talking about a rational exponent. So say, for example, you have 8, for example, to the second power. We know that 8 to the second power is 8 times 8. 8 used as a factor 2 times, multiplied times itself, and that's 64. Now, what if we had 8 to the 1/3? Okay, so if you haven't seen this before, I know it looks weird to have a number to a power that's a fraction, but all this is a radical. All right, so basically, this is a way of expression. We're about to show you how to express this rational exponent that's in the form of a fraction. This basically translates to the following. So 8 to the 1/3 power is otherwise known as the cubed root of 8, the third root of 8. Okay, so it's 8 to the first power that you're taking the third root of. That's what that is. So 8 to the 1/3 power is the same thing as 8 to the first power. You're not going to necessarily keep that there, so that's why I don't have it. and you're taking the third root of it, okay? All right, and so we know that that is the cube root of 8 is a number that if we multiply it times itself 3 times, it'll give you 8. So it's 2. 2 times 2 times 2 is 8. All right. So let's do something else. What about if you had 8 to the 2/3 power? Expressing that with the bracket thingamajig, you essentially have 8 squared, and you're taking the cube root of it. So it's 8 to the 2/3 power is the same thing as 8 squared, and then you take the cube root. You see? So there's the 2 right here, and then the 3 in the denominator is the cube root here. Okay. So if we were to find that, 8 squared is 64. So let's keep on writing that out. So we want to find the cube root of 64. So what is a number that if you multiplied it times itself 3 times as a factor, it would be 64. 4. So 4 times 4 is 16. Times another 4 is 64. So the cube root of 64 is 4. Okay. So that's all that is right there. Now, okay, so let's keep on going. So let's kind of make a general, I guess, formula, if you will, for this. So if X is real, and let me actually type this because I type faster than I write. And I'll leave some spaces so I can really write this. So if X is real, that means it's not imaginary. It's not a number that has like an I after it. And M and N are positive integers such that it's a real number. Then and I'm about to fill this in, I promise. Okay, so let's drag this out. I left spaces there because some of this stuff I have to handwrite because I can't really type it. Okay, so if X is real and M and N are positive integers such that the nth root of X is a real number, then X to the M over N is expressed as either of the following. So let's look at this again. If X is a real number, and then M and N are positive integers such that when you take the nth root of X, it's still a real number. In other words, that means that whatever X is, either N is an even number and then X can be positive or negative, or if X is negative, then this is going to be like some sort of odd number because you can take the cubed root, you can take an even number root of an odd number, but you can take the odd number root of a negative number. Sorry, I'm kind of mixing stuff up here, but you cannot take the even root of a negative number and then get a real number out. You get an imaginary number then. But anyhow, X to the M over N is expressed as either the nth root of X to the M power or the nth root of X to the M power all underneath the bracket. Okay. All right. So let's do another example here. I'm going to go ahead and let me try to erase all this stuff here, create myself some space. Okay, almost there. All right. So what if you had 8 to the 5/3? So remember, you can write this as either this, or you can write it like this. Okay. And it tends to be advantageous sometimes to do one over the other. So we're going to do this one here. So we're going to write this as the third root of x. I mean, not x. We actually have a number here. Sorry about that. Third root of 8. And then all of that is to the 5th power. You see? So it's easier to do it this way because we know what the third root of 8 is. And then we can put it to the 5th power. So the third root of 8 is 2. So that's going to be 2 to the 5th power. So that's 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Okay. All right, let's do one that's a little bit weird looking, but don't let it intimidate you. So let's say you have, so that's number 1. This is number 2. 8x to the 6th power, y cubed to the 5/3 power. Okay, it's a lot going on here, but anytime you have a lot going on like this, just take your time. Just take your time. So let's rewrite it using that form. So that becomes the third root of 8x to the 6, y cubed, and all of this is going to be, to the 5th power. Okay. So we can take the cube root of each of these pieces, look at it one piece at a time. We know what the cube, and since all this is multiplied times each other, as you take the cube root, you pull that, whatever that root is out here, and it's going to be multiplied times each other on the outside too. So the cube root of 8 is 2. And remember, all of this is going to end up being to the 5th power. The cube root of 8 is 2. The cube root of 6 is, and keep in mind, you can look at this a couple of different ways. When you have this x to the 6th right here, cube root, that's just like x to the 6/3, which would be 6 divided by 3 is x squared. You see? Or you can say, what is the cube root of this? What can I multiply times itself 3 times to get x to the 6th? So x squared times x squared times x squared gives you x to the 6th. So that means the cube root of x to the 6th is x squared. So that's 2, bring out an x squared. And then the cube root of y to the 3rd is just y. Y times y times y gives you y to the 3rd. Okay. And then, so we've been able to do everything on the inside of there. There's nothing else left underneath. So now we do this to the 5th power. So then 2 to the 5th power is 32. X squared to the 5th power is x to the 10. And then y to the 5th power is y to the 5th power. There you go. Okay. So if you take your time, it's pretty straightforward. All right. Now let me erase all this because it's going to be easier for me. Now I just want to do a couple of quick rules for radicals, and I will have you on your way. Make sure that you take your time and understand this stuff, and we'll go from there. So let's talk about the product rule for radicals. All that is basically, if you have the nth root of the product of a couple of numbers, it is the same thing as the nth root of x times the nth root of y. Okay. So for example, if you had the square root of 32, that you could break that up into square root of 16. Well, here, let me do it this way because I'm skipping some steps. So you could say, okay, 32 is 16 times 2, right? So using the product rule, then I can break this up into different roots or whatever. So that would be the square root of 16 times the square root of 2. Now, this 16 is a perfect square. So, because 4 times 4 is 16. So that's 4 times the square root of 2. You see? All right. Now you have the quotient rule. For radicals. So which that basically says if you have the nth root of a quotient, which is division problem, answer to a division problem, that is equal to the nth root of x divided by the nth root of y. Okay, so let's illustrate that. With this example, I chose a nasty looking example, but I promise you it's not that bad. So say that you had the following. Oh yeah, but before I say that, keep in mind, y cannot be 0 because you never wanted a 0 in the denominator because that is an undefined situation. All right, so say for example, you had this 2 over 5x times the square root of 75 x to the 4th. Okay. So is that the example that I want to use here? Actually, that's not the example I want to use here. Let's do this one here. Yeah, sorry, y'all. Sorry about that. Let's come back here and do this. So if you have square root of 5 over 3, that's equal to the square root of 5 over the square root of 3. Now note another thing. You cannot have a square root in the denominator. You can't have a root in the denominator. You have to do what's called rationalizing the denominator, which is get that root out of there. And so the way that you do that is to multiply that times, you multiply that times square root of 3, because you figure if you have square root of 3 times the square root of 3, that'll just be 3. Because think about it this way. Square root of 3 is the same thing as 3 to the 1/2 power. If you multiply it times another 3 to the 1/2 power, you add those exponents. So 1/2 plus 1/2 is just 1. So that's 3. So we're going to multiply the top and the bottom by the square root of 3. And so that becomes, using the product rule for these, 5 times 3 is going to be underneath that bracket. It's going to be 15 over 3. Square root of 15 over 3. Okay, so that's an example of using the quotient rule, but also an example of rationalizing the denominator. Okay. All right, so let's go back to that example of what I was just doing. That's kind of more of another example for the product rule, I guess. Okay, so we'll do that, and then maybe we'll have time for one more, and then we'll call it a day. So 2 over 5 x times 75 x to the 4th power. And keep in mind, we really want to make sure that these are simplified at the end of the day. So let's simplify what we can over here. So we already know the square root of x to the 4 is what can I multiply times itself to get x to the 4? You know, what times what to give you x to the 4th? X squared. X squared times x squared is x to the 4th. So you can pull out an x squared there. So let's do that. So that's 2x squared over 5x times the square root of 75. So we can use the product rule to figure, but before we do that, let's simplify this. You have x squared up here and an x down here. So x squared over here and x down here, those can kind of simplify. So this goes away and this becomes just x, because it's x squared divided by x. Okay, so let's rewrite that. So that's 2x over 5 times the square root of 75. Now 75 we know is, using the product rule, that's 25 times 3. So we can take the square. So we'll rewrite that again using the product rule. So that's the square root of 25 times the square root of 3. We know the square root of 25 is 5. So it's 2x times 5 times the square root of 3 all over 5. These 5s cancel out because 5 divided by 5 is 1. And your answer is 2x times the square root of 3. Okay, so we use product rule there, no quotient rule really. But this last one that we'll do is an example of the quotient rule. So let's do that, and I'll let y'all go on to another video. Let's say you want to do square root of 3x to the 7 divided by 8x cubed y to the 5th. All right, so this one is a little bit involved here. So let's see what we can actually pull out of here. So we're gonna do a little bit of also like I guess product rule. But first of all, look here. You have x to the 7th up top, then you have x cubed in the bottom. So x to the 7 divided by x cubed is x to the 4th. Remember, when you have like something to a base to a power, and you have the same base to another power in the denominator, then you just subtract the exponents. So let's go ahead and do that. So this becomes 3x4 up top, and then you have 8y5 at the bottom. Okay, so we know we can take the square root of x to the 4th. That's just x squared. Okay, so that is x squared times everything else. 3 over 8 y to the 5th power. Now let's go ahead and apply some quotient rule here. So this becomes x squared on the outside, then you have square root of 3 all over square root of 8 y to the 5th power. Now we're going to do some product rule down here to kind of break it up to see what we can actually pull from underneath that square root. So that becomes the following. Because I know that 8 is 4 times 2. I'm gonna write it all out over 3. So let's do this. So 8 is 4 times 2, and then times that variable, that's times y to the 4th times y, because y to the 4th times y is y to the 5th. 4 times 2 is 8. Just keep in mind, I'm only breaking this up just so that I can pull whatever I can out from underneath that square root. So this becomes x squared times square root of 3 all over. The 4 comes out as a 2, and then a y to the 4th comes out as a y squared. And then what stays underneath? 2y. Okay. All right, good. So we're actually almost done. So now we need to rationalize the denominator, and we do that by multiplying any root in the denominator by itself, and that just automatically gets rid of that bracket. So we're going to multiply that times that, and whatever you do to the bottom, you have to do to the top. So that becomes x squared times, now we're multiplying square root of 3 times square root of 2y. So that's square root of 6y. And then that's all over 2y squared times, and when you rationalize that, that's square root of 2y times square root of 2y, which is just 2y. Uh-oh. Now let's go ahead and finish that. So that is x squared times 6y under the square root divided by 2 times 2 is 4. Y squared times y is y cubed. And that, yes, is your answer. So kind of involved, but just take your time. Look for wherever you can use the quotient rule. Look for wherever you can do the product rule. Make sure you observe all of your rules when it comes to multiplying and dividing with exponents, because whenever you multiply two bases that two numbers that are like to a power and they have the same base, you add the exponents. When you're dividing two numbers of the same base with different exponents, you subtract the exponents. So remember that stuff too. All right, remember, if you need tutoring, go to calendly.com/MathSwap tutoring or call 478-254-0515 and subscribe to this YouTube channel. Subscribe also at mathswaptutoring.com/subscribe to make sure that you get copies of our notes. Okay, thank y'all, and keep on watching these videos and make sure you let me know if they're helpful or not. Thanks.